Alright, what you're looking at is a P51D Mustang. It's a 1400mm model and it's by FMS. It originally came with the FMS transmitter and receiver. I'd highly recommend not using those. I fortunately didn't put it in this and use it, but I did put it into a little hackabout, and it lost signal after about 15 metres, and the model, after we recovered the parts, we did a range test. Perhaps we should have done a range test before we flew the aeroplane. However, we just threw it in and we're flying a very small park, figured the range would be ample, and we worked out that the FMS transmitter and receiver was losing quality of signal probably within about 12-13 feet. Jittery servo travel, and then after about 15 metres, so about 45 feet, basically there's no travel at all in any of the servos, so it's a good thing I didn't put into this. So I highly recommend not using the FMS transmitter for a bird like this, and get another transmitter. The minimum you would need would be, say, Spektrum, if we talk Spektrum DX8, and that would give you flap and retract, which is what it's got. The purpose of this video is to show you what you can do if you decide to then move from a DX6 up to a DX8, and the functionality of the DX8 in regards to the retract and the flap system, which will allow you to create a scale look. If you were having something like a DX6 or a standard 6-channel, you'd have a simple on-off switch for your retract and flap, so it would look similar to this: flap down, flap up, flap down, flap up, retract down, retract up, retract down, retract up. You get the hint, you get the picture. But basically, from a scale look, it just doesn't look right, because the old warbirds, they had a hydraulic system where the hydraulic system wasn't completely balanced, so it would work really hard on one side and pretty low on the other. So one wheel would usually come up before another. In some systems, it would fire one wheel first. It would even to the point of hold. The other wheel would then take over and kick up and then close, and then the initial wheel would then come up and follow afterwards. So there's nothing scale about that, and certainly the speed of the flaps, definitely similar sort of thing, nothing scale about that either. So a DX8, what it does, and at the time I was looking to buy a transmitter rather, the DX7 and the DX8 were the two I was looking at. I was looking for JR, but because I do a lot of park flying and I really wanted a UMX beast, I had to stick with a DX8 or a DX7 sort of model, because it was backward compatible with the DSM-2. So I think the main differences between the 8 and the 7 were, other than the channel, was that the 8 has 3-position switches for all the dual rates and for the mixed switches, whereas the 7 only has a 3-position switch for your flap. The other thing that was quite good was the telemetry module came with the 8 in the package, and it was an additional $110 on top of the price of a DX7. So overall, the difference of $150 retail I couldn't justify not going to the DX8. But the advantage the DX8 has over the DX7 is in the servo speed, and what it allows you to do is control the speed of the servo, so that you can choose the duration it's going to take from one extent to the other. And today I'm going to show you how to set that up on the DX8 so you can make your warbird look a little bit more scale, so you don't get that sort of ugly look. The first thing you have to do, and the main reason for getting the 8 channel over a 6, is that you have to separate the gear from the channel 5 and put that into 2 separate channels. So in a standard model, or like the FMS, channel 5 is split out using a Y cable, so both the gears work off the one channel. Both the retracts work off the one channel. So we're going to remove that Y cable. And ideally you should do this with the power off, but I'm hoping I'm not going to shorten any wires. I'll put things in the wrong way. So I'll put one of them back into the gear component, and the other one we'll put into auxiliary 3. The flaps I have running auxiliary 2, and what I'll show you is the flaps first and how we can control the speed of the flap to give it a much more scale look. Alright, now first thing you note about the wheel is you see that one of the wheels has now gone down to a 45-degree angle, which is a mid-range between the full extent of a wheel down and wheel up. That's because the servo at this stage for auxiliary 3 still thinks it's a standard servo as if it's used for an aileron or an elevator, which would have an up and down travel. So we have to do something with the system to tell it that it's got to have the full range, so that at one point it's all the way open and at the other point it's all the way closed, which we'll show you shortly. Alright, so flap still at this point, fast flap. Gear, because we've split the channel, is now only one side working. So we've got to do something to get that other side now to pair with the gear as well. And we're going to use a program mix for that. So the first part of what we're doing now is we're going to assign speed, servo speed to the flap. So hopefully this is going to work so you can see this. Alright, so from the main screen we move to Servo Setup, and our flaps, so change that to speed. Our flap is on auxiliary 2, and we can increase this up to 30 seconds, but I'm going to move it to say 5 seconds for a complete throw from stop point to stop point, and it's as easy as that. If we go back to our model and we look for the flap at the back, full flap range now takes 5 seconds. And of course, because it's a 3-position switch, we've got position 1, position 2, and then full flap range. So that's how easy it is to give it a scale, really nice looking scale flap coming down. You could even probably put it to 4 seconds, 4 or 5 seems okay. I don't even know what the actual time it takes for the full size beast, but yeah, I think 4 and 5 looks pretty good. Alright, now from the retract side of things, there's a bit more work involved. So back to our menu. Okay, so again, servo setup, we're going to control the speed of the servos. So we're going to have one gear is going to travel at 2 seconds. So our right gear, the one left-hand gear for the aeroplane, but right-hand for what you're visually seeing. That's going to take 2 seconds to close up or come down. And our channel 3, we're going to give that a 3-second time. Okay, now with this as well, we've got to change and mix, so we can mix the two together. And we're going to use mix 1, and the master will be the gear, so channel 5, and we're going to assign the slave as auxiliary 3. Now because it's set at 0 for our auxiliary 3 is set at 0, we have to tell this system that we're going to change that servo so that it works from 0 to 100. And to do that, we change the rates all the way up. Now in this current state, what I might do is, I'm just showing you I'm increasing the rate. I'm going to come back and show you how that's affecting the servo. So as I increase the rate, down comes the servo, down comes the wheel. And so I'm going to increase that up to 100. So it's on 100. And now the other side, of course, is we have to make sure that on the up that it goes past the 45. I'm going to increase that to 100. So I'm not even going to set any offset between the two. We're going to have, this is pretty important, you're going to have the switch, hopefully you can see that I haven't gone out of focus. You're going to have the switch is on, and make sure it's on all the time. So that means that it doesn't matter what other function switch is on, it's always on. If you're using the F switch, for example, if I change that switch and use it to FM2, automatically, even just the default settings of how the switches are, you're going to see that the retract has come in. Now you could be flying around and you could bump any of your switches and not be in the right mode. So you can be flying down, drop your gear, bump your switch on landing, and all of a sudden your wheel folds up like that, which is not good because on this particular aeroplane, of course, it's a servo retract, so it's going to take the weight on the servo itself, and it'll fold pretty easily. So really important, make sure that your switch is set to on. And that's pretty much it. You can do other things to mix it, but if we now flick back to the aeroplane, you can see if I throw the gear, we've got a closer to scale looking retract system. And you can delay that out even further, so if it was 4 seconds, it would look a little bit different again. So scale retracts, scale flaps, all with the DX8, and just simple functionality and parameters inside the model. I hope if this has helped you, if you've got a DX8 or if you're looking at buying a new transmitter and you're basically thinking of going to maybe a JR 9303 or a 9X or something like that. I love the DX8 now. I think it's fantastic. I think for everything I need, it's got pretty much everything I need and more. So yeah, hope you enjoyed the video.